So in today's session, I'll basically take you a little bit through some of the background context around Gen AI and our product portfolio that helps Gen AI developers. Take a peek under the hood and maybe dive into some of the AI models that power retail search. And then we'll try and get into some of the cool, exciting work that we are currently doing around LLMs and how they can actually improve relevance in retail search. And bookend it with like some of the customer success stories. Oh, maybe I should introduce myself. I'm Chandra Prasad. I'm an engineering director in cloud AI and industry solutions at Google and GCP. And in case you're wondering if I look different there, it's not a generated AI picture, but it's just me when I joined Google, so it's a little bit old. So let's take a look at some of the background for today's talk, and I'll try and give you a little bit of a broad context before we dive into things in detail. So if you put together like a word cloud of all of the technology trends that have happened in 2023, I can guarantee that generative AI and large language models would dominate that entire word cloud. If you think about the opportunity that LLMs provide, it's tremendous for us to be able to innovate and to drive business growth. But processing the large amounts of complex data and being able to extract that information is pretty resource intensive. So it's not accessible to all enterprises. However, large language models have processed pretty much all of the world's publicly available information, whether it's text, whether it's images or audio, and made it available to enterprises to use in a convenient and easy to use interface. So if you look at how LLMs work, they understand humans more intuitively. So it gives us the opportunity to be able to use this understanding of humans to create seamless and more natural interfaces and online experiences for our shoppers that is much more in tune with what they expect in today's world. But if you go back, most of what people think about in terms of generative AI or LLMs is really about content generation, right? So that it's really helped enterprises make their employees more productive. But that's not the only way in which we can use these large language models. Depending on the expertise that you apply to the problem, enterprises can take them and customize them and integrate into their existing solutions and in their technical infrastructure. So in order to be able to do that, GCP provides a set of tools that's called Vertex AI Portfolio. And what we've tried to do is to bring together all of the tools that a Gen AI-centric organization would need under one brand. So if you look at Model Garden pulls together all the best of first-party, third-party, and open source models into one easy place that's accessible for enterprises to be able to prompt, tune, and distill. And there's over 100 models that are accessible right now. The AI platform is targeted more towards data scientists, and it's used to manage the entire life cycle of your AI model, all the way from experimentation to training and deployment and production. But more importantly, it provides extensions and several data connectors to important data sources that allows us to bring in the data. And even more importantly, it lets you ground the answers that the LLM gives in the corpus of your data. So it doesn't start hallucinating and creating stuff that it shouldn't be doing. So it's really grounded in your corpus. The search and conversation layer provides developers a way to build innovative Gen AI apps that really, the promise of seamless user experiences. And developers can either leverage the Jumpstart kits that we have or directly access the SDKs, APIs, and libraries to develop their applications. And putting it all together, the AI solutions is a set of very powerful AI agents that allow business users to get their job done. And so some of the examples there are like contact center AI, anti-money laundering AI, discovery AI, and document AI, right? In addition to what Google provides, there's a whole broad ecosystem of partners who build out solutions on top of Vertex AI and bring it to our customers or their customers. And many of these solutions are being used by customers like Replit or Typeface and GitLab. Last but not least, all of this is built on top of Google compute and cloud infrastructure that is highly optimized for machine learning workloads and provide deep connections into the Google Data Cloud. So in the world of retail, has been in a constant state of flux. Things are being disrupted, we have to transform ourselves, and this journey has been going on with entities breaking, can I just ask that door to be closed, if you don't mind? Thank you. So many entities who are basically changing the steps in the value chain so that they use existing models, but are changing the model to be able to provide better customer experiences. And the pace of innovation is evolving rapidly, and it also makes it difficult for us to keep up. Customers of today expect things like seamless digital experiences online. They want to be able to have personalized experiences that goes across channels. They want to be able to look at inventory levels and availability of product. They want to pick the channels for fulfillment. But these are all expected, and this is continuing to evolve. And in order to be able to serve these customers, we need to innovate quickly, be able to pick the best of breed solutions that exist, and focus the enterprise on the hard problems that nobody else is solving. And while technology has traditionally been part of multi-year plans for retailers, we increasingly see it as something that is a in-year value driver with concrete short-term benefits while setting up the enterprise for long-term success. So what does this all mean, really? If you look at the shopping journey, the steps in the shopping journey have pretty much remained the same over the years, except the way that shoppers are interacting with technology in each of these steps has evolved tremendously over the years. We can continue to drive this evolution by using the latest techniques we have today with Gen AI and AI, especially since shoppers are much more willing. First of all, they're much more conversant with technology. They've been used to using this, and they're much more willing to try new things as long as it provides them value. So the whole intent here is to be able to do this innovation in a way that's pragmatic. Can we think about return on investment, time to getting return on investment quickly? Can we make sure that we can integrate these things into existing technology stacks, and yet make sure that these technology stacks are open for extension in the future? So providing these kinds of experiences and being able to get customers to shop is a pretty big challenge that retailers are trying to navigate through. It's often very hard to understand user intent and to be able to personalize and surface the right products so that they actually buy. So if we don't do that well, we leave a lot of money on the table. And these are some of the numbers that show how not having the right personalized search experience that gives customers what they're really looking for can do. To help retailers along this journey, Google Cloud has this thing called Discovery AI, or product discovery solutions. It's basically 3 products that are converged together in one offering. There's Vision Product AI, Recommendations AI, and Retail Search. So Vision Product AI, you can just think of it as like Google Lens, for those of you who use Google Lens, on your own mobile app experience. So it helps shoppers as well as in-store associates be able to quickly look up an image of a product and see related products from your product catalog or in the store using AI. Recommendations AI is geared towards delivering personalized experiences for your shoppers across all channels. And retail search provides the Google quality search results that really looks at what the shopper's intent is and making sure that the products that are being returned as part of those search results are relevant. So whether you're using search or browsing, and browsing is basically looking at product categories, or using recommendations, the thing that these three products do is personalize the shopper's journey through the entire experience. So Discovery AI really tries to provide relevant search results and personalized experiences that allow customers to be able to do queries that maybe the retailer hasn't seen in the past, but we understand the intent. We have a really good way of having query understanding that use a lot of signals from Google Shopping and customer behavior on Google Shopping that says, hey, are these the kinds of relevant products based on the queries that they've done, and brings that to the retailer so that you don't have empty search results when somebody does a query. Or it's not relatable to the actual shoppers that understands their personal preferences or their tastes and habits. So with that background, let's take a quick peek into under the hood. Let's open up the hood and see, walk through some of the models that actually are used in retail search and browse. So just stepping back a bit, search has two big problems: relevance and ranking. And each of them is important for different kinds of searches. So what is relevance really? Relevance is really trying to understand the shopper's intent and saying, what is it that you're really looking for? And the search results actually reflect what you are really looking for. And it's extremely important for what we call tail queries. Tail queries are bespoke, like uncommon queries. In this case, it's like high-waisted ripped boyfriend jeans. When someone's coming up with such a bespoke query, they're very sure about what they want. And if we don't give them relevant results, it's going to end in an abandoned search session, right? Ranking, on the other hand, is a different kind of problem. I can get all the relevant products that satisfies the shopper's search intent. But what order do I show them in so that I maximizes the chances of them clicking on something and purchasing it? So if somebody searches for something very generic, like say women's pants, there's a lot of products that would fit that search result. Except showing them in random order will not guarantee that you will really get someone to click on it and buy them. So let's take a sample query, right? And let's say short-sleeved long dress. All of us understand what that is. But if you think about legacy systems that use text-based search, it's a very hard problem because they look at individual words, short, sleeved, long, and dress. They don't understand the relationship between these things. And therefore, just looking at it from a word count or a matching words, the kinds of products that you show will not really reflect what the search intent was. And what this does is it requires the retailer to be able to put a whole ton of manual rules that says, hey, by the way, this is what you need to filter it by. So this is a whack-a-mole, right? So as you find more and more queries that you've never seen before, you're adding more and more rules. And there's another downside to this problem. The best thing that you can achieve out of the system is to be able to sort or rank these results based on how relevant they are. But really, that's not what you want to do. You want to be sorting them based upon what the shopper's trying to click and purchase. So what retail search does is it has a lot of learning from Google Shopping and our AI expertise, and we bring this to retail search to identify relevance without really looking at words, right? So this is where I think large language models would come in. So let's take a look at the first kind of model that we have. It's a language model, and the purpose of the language model is to take a raw query, which is free-form text, and convert it into a structured query. This is where some of the hard keywords have to be interpreted. For example, if you say large, large could mean, in context of hardware or nails, it could mean nails that are 4 inches or longer. But in the context of mattresses, it's king or queen. So you have to really discern what the intent was in order to be able to interpret these hard words and convert them. So once you get this, then you also start looking at doing language-based filtering. So for example, someone's looking for a blue blouse. You go, oh, I think I know what that is. The product is blouse, and I'm going to filter on the color blue. Except it's not that simple. I can search for red blue jeans, right? There's no such thing as red blue blouses, but there's red blue jeans. So you have to have an understanding of how humans use the language for this to be able to convert it into a structured query that can then be passed on to the relevance AI. So the relevance AI is a bunch of different relevance models that are then combined together by another AI. And in this case, we've got years of humans running queries on Google Shopping and clicking on the results. We know what they clicked on and what they didn't click on. So by doing that and observing that behavior, we're able to discern the intent that the customer or the shopper had. It's like, okay, when they say short-sleeved long dress, these are the kinds of things that really matter, right? So this is extremely important, and this is the data or the knowledge from Google Shopping is used to train the retailer's model, and not the other way around, by the way. So we don't use any of the data that comes from the retailer's model to train any of our AIs, but the Google Shopping data is used to train the retailer's model. And one other thing, so it doesn't really matter which retailer is selling the short-sleeved long dress. A short-sleeved long dress is independent of the retailer, so it's very general human knowledge. So after the relevance AI goes in and gets the relevant results, it takes the top 400 and sends it off to the ranker. But before we go there, one of the areas that we're really excited about this year is the work that we're doing on LLMs and how we can improve our relevance AI. And so I'll speak a little bit about this in a later section. So the relevance AI then goes and says, okay, let me take the 400 top results, ship it off to the ranker so it can show them in the right order. So the ranker gets your relevant results, the processed query, and we also get user events from the retailer. So what do we do with these user events? The first thing that we do is to send it to the personalization AI. The personalization AI basically only operates with the retailer-specific user events of the user behavior on their particular site, right? So we kind of look at what do they search for? What have they browsed? What kinds of things do they click on? What have they added to their shopping cart? And what do they really purchase, right? And once we do that, we can start by the way, we don't look at demographic data. We don't look at their behavior on other retailer sites, nor do we look at how they behave on Google properties like YouTube or Gmail, but it's really their behavior on a particular retailer site. So once we do that, we can start extracting some patterns, purchasing patterns, or user tastes. I think I know what kind of products you like or you usually purchase, what brands you prefer, what are your preferences in terms of size and color. And then we put it together, and then we can also do some correlations. Like some of our tastes in shoes might correlate to our tastes in accessories. But our tastes in lumber aren't going to translate to our tastes in faucets, right? So it knows what things are correlated, what things are not, and starts learning a little bit more. And then also looks at time-based patterns. So let's say I buy dog food for my dog every month. If I had purchased dog food a little bit more than a month ago and I went and searched for dog supplies, I hope I see dog food in the top of that list because it's time for me to buy the dog food. But if I just purchased it last night, it doesn't make any sense to have it on the top of my list. So it learns these patterns over time and then uses that information and provides them to the ranker. So what is the ranking AI really trying to do? It's really trying to figure out what is your likelihood of making a purchase so that I can rank the items in the search results in the order of most likely purchase, but more importantly, not just likely purchase, but highest expected revenue, which is really like the likelihood of purchase or the probability of purchasing this item times the product price, right? So how does the ranker do that? It starts looking at things like, let me take a look at all the different things that people bought for this query in the past. I have an idea of what that is. And then it starts analyzing trends over time. And then it folds in things like your personal preferences and tailors those search results to your particular shopper. And again, as we said, and then it takes a look at your expected revenue and ranks them based on that order. So going back to our query, short sleeve, long dress, you can see it's processed very differently from legacy search applications versus what an AI-first approach would do. So in the legacy application, it's about word counting. It's trying to make sure that we put a lot of manual rules to start constraining the problem. And then still at the end, what you get are the results ranked by what is most relevant or based on those rules, as opposed to an AI-first approach where we've got relevance because we understand the search intent. We know what people are trying to do based upon examined human behavior from the past. We start ranking them based on the most likelihood of purchase. And then we use personalization AI to make sure that it's actually tailored for that individual shopper, which then allows us to figure out how do we learn over time. So the AI curates itself and it learns from its mistakes. It's self-testing and self-optimizing. And the holy grail is finally the AI sorts the products to maximize your revenues, right? So let's go a little bit into browse. So browse is, I don't want to do a search. I already know the category I want, and I go, pants / right? I just go into pants. Since we understand the user, we optimize the way in which we show the products to personalize it and to optimize our conversion rates, right? Then there is the other part, which is if you go to a site, you'll see all the filters. I want to filter by brand. I want to filter by size. I want to filter by color. These are called facets, and the facets are actually determined by the retailer. However, we can use machine learning and our AI to figure out, oops, I didn't want to do that. How do we make sure that we show the values for the facets? For example, a facet's size would have small, medium, large, extra large. We want to show you the ones that are most commonly in use for that query and for that user. And we dynamically order the facets based upon which ones are most often clicked, right? So that way, it gives a much more seamless experience to the end user. Now, we talked a little bit about the different AI models and how they allow us to understand user intent and to be able to rank all the products based upon expected revenues. But there's also different levels at which you can integrate into Discovery AI. You don't have to go all the way from 0 to 5th gear on day 1. And so you can graduate yourself. And in order to show how this works in the product, we have our product manager, Noah, who unfortunately couldn't be here, who's going to have a little bit of a demo, a show of the product and speak through some of the things that we've done to make it easy for us to integrate into the different tiers of the AI.
Hi everyone, I'm Noah Freeman. I'm the head of product for Cloud Retail Search, this product. And while I can't join you in person, I wanted to take this opportunity to demonstrate two new features that sort of show you how the product works and that we've also just released. The first is our auto upgrade system, where the model operates in one of 4 modes. And those 4 modes are relevance only, where it sorts products using Google Shopping relevance in descending order of relevance. Then it has relevance plus popularity, which looks like relevance mode, except that it breaks ties for better selling products. Then there's revenue optimized mode, which is expected revenue ranking that we've discussed. And then the last upgrade is to personalized revenue optimized mode, where it also enables personalization. And this dashboard lets you see which mode you're in, and the model will also auto upgrade to the best mode it has the right data for. And so you can see where it is, and then what this module also gives you is the ability to see what data is blocking your upgrade to the next mode. So you can, as a user, not only understand what mode you're in, but what data fixes you need to put in place to get to the better modes. And while it will work great in any of the modes, the performance is by far the best in mode 3 and 4. And so one of the things we spend a lot of time with our clients who onboard is helping them pass the data quality checks so that they can get to at least mode 3, where the giant revenue performance typically comes out.
So I'm sure Noah wasn't too happy not to be here, but he had other things that he had to take care of. So with Discovery AI, we talked about some of the challenges as retailers have, making sure that we provide the right kind of experience to really end in a purchase and maximizing revenue. Discovery AI helps navigate through many of those challenges informed through Google Shopping to really uplift some of the key metrics. But if you see some of the metrics there that shows averages across our customers, but the one that you need to pay attention to is revenue per visit. That's really what you're trying to optimize for, because anytime someone comes to your site, you want to really maximize that revenue. And how do we do that? It's through all of the understanding of the query and search intent. We really avoid the catastrophic scenario of abandoned searches, because that could have a huge drag on your revenue potential. And on top of that, by ranking them based on the most expected revenue and personalizing that experience, you're really seeing these kinds of uplifts that across customers. Okay, so that was a little bit of a peek under the hood with all of the different models that we have. Now, typically in Next, we've always been about what is in the product. But we're really excited about some of the work we're doing right now in LLMs. I mean, I think we've run a few pilots across a few select customers, and we're seeing some really great results. Of course, there's a lot of work to be done. There's a lot of work to be done to make sure that these generalize beyond those people that we're working with. And can we really meet the constraints of latency for having these LLMs in place? Because as you know, the LLMs can be a little slow. So again, when people think about LLMs, the first thing that comes to mind is generative AI. And they're really good at it. It's imagine that you have a really smart student who's read every book in the world and in every language. So they have a pretty good understanding of what humans want to do, or how they speak, or how they create. So if you were to go in and use an LLM to say, complete the sentence for me, I fed my black blank, it's going to come back and say, there's a pretty good chance that it's cat. And maybe it's a dog, but definitely not a helicopter, right? Maybe right, it may be wrong, but that's, it's probabilistic. But that's not the only way we can use LLMs. LLMs can be used as regression LLMs, or we call them relevance grading LLM. You can ask the question like, hey, does a yellow Acme roofing hammer, what is this relevance to a contractor's hammer? And the relevance grading LLMs come back and says, oh, it's 95%, it's relevant. So, so the output of a relevance grading LLM is a number, as opposed to text, audio, or images. So you can go try this out, by the way. If you go to Bard and ask these kinds of questions that we asked them, said, hey, yellow Acme roofing hammer, is that a hammer? And it says, yes, 100%. Is it a contractor's hammer? It goes, most likely yes. It's like 95%. And then I ask it, can I get a hammer as a gift for my child? And it goes, not such a great idea, right? It's probably like 20%, unless I have a very, well-coordinated kid who really loves building things. It's likely that hammer for a kid as a gift isn't really a good idea. And then you ask it the question of like, how about like a couple that's getting married who are hobbyists? Can I get an Acme yellow roofing hammer as a wedding present? Like, no, not a good idea at all. But if they were hobbyists and I said yellow Acme glue gun, that's a pretty good number. It says 90%. So, it's used in crafts, and maybe there are crafting couples, so it's actually a reasonably good idea. So you can do this today with Bard, except we're not going to be using Bard for our retail search. Obviously, we want to be able to return results in a meaningful time latency in millisecond without really melting a server farm. So what are some of the ways that we're thinking of using relevance grading LLMs in our solution? The first step is you recall things from the catalog. You get products from the catalog, you have the query, and you're then trying to figure out how do you calculate relevance. So in the relevance grading, we could use LLMs in the relevance grading, right? And say we can use the relevance grades and then teach all the systems downstream to use that better relevance to provide better ranking and therefore maximize the revenue. Or we could take a slightly different approach. We could embed that relevance LLM inside of the revenue grading and says, is this something that is going to maximize your revenue? Is this something that's a good idea to show? If I were to show this item at the top of the list, what is the probability of getting revenue for it? And therefore, how much revenue will I get based on the product price? And then I can get more granular and better estimates of the revenues estimates in the final ranking, and therefore still improve your final ranking. So there's a couple of modes in which we're experimenting in. We're working, as I mentioned before, we're working with a few select customers on pilots, and we've been really astonished at the results. Again, it's very early. We still have to make sure that this approach is feasible from a compute infrastructure perspective, from a latency perspective, from a user experience perspective, and that it's generalizable across multiple retailers. So the idea is we're going to continue to work on this, and we'll see how things progress, and hopefully you'll be hearing more from us soon. So with that, I want to bookend this session with some of our key customers who've been able to deploy Discovery AI in their retail sites and see what kind of experience that they've had. So Shopify has been making Discovery AI available to all of their enterprise customers across the globe in multiple languages, right? So it's a pretty difficult thing to do in traditional systems because you then have to think about translating queries. You can't just translate apple to pomme in French. Unless it's an Apple Watch, right? So there are a bunch of things that you have to think about. So they've brought this to all of their enterprise customers globally. FNAC Darty is a multi-branded French retailer that had a problem with a really, really large catalog, about 20 million products, and trying to sell this across multiple brands in different languages throughout Europe. And they're starting to use Discovery AI and roll out to the multiple retailers that they have. Lowe's has been one of our earliest customers. One of their biggest challenges was abandoned queries because people would use bespoke search terms and they would end up seeing almost 15% of their searches being abandoned. So now, using better relevance and better query intent discerning, they're able to capture a lot more of the market share by not having no search results found kinds of abandonment. abandonment. And Macy's is also one of our early customers, and they've been using Discovery AI to improve their shoppers' experience on their digital properties. Now, hopefully, all of this has given you a little sense of the kinds of things that we can do in terms of retail search and product discovery. And while the whole shopping journey is still the same with the same different steps, each of those steps are evolving rapidly. And given our experience with Google Shopping, it's been informing a lot of what customers really are looking for that we can bring to retailers. And by continually working on our AI models to make sure that we optimize on the expected revenue, we are able to deliver value to all of our customers.